Hi everyone, here's Simone. This is tutorial 20. Oops. And today we're gonna speak about TD modules, TDU module, and we're gonna also build a value normalizer in GLSL. Okay. Why those things are useful? Hope I will explain you. Okay, so TD modules. How to arrive to this page? First, go to the derivative website and then you type TDU. TDU, and you type, then you search for TDU module, and you are here in this page. Those are functions embedded in Touch Designer that we can easily call and use if we want. Okay. One of the most famous and common is the random seed. Clamp is self-explanatory. Remap is nice. And then there's other that you can explore yourself. Another one that I did not mention is the TDU path info that tell you where is your project. Okay, first you make a TDU dependency. You can send value in Touch Designer by exporting with Python, exporting with Chop. You can bind them, but you can also use Python to move value around. In this case, the TDU dependency is kind of redundancy, but we are making sure that this value from the sender will always go to the value of the receiver, like this. Nothing special, but this is what is a TDU dependency. You are connecting to value, and you are making sure they remain connected. When you make big things in Touch Designer, this is really important. Make operator cook when Touch Designer forgot to do it. Okay. Okay. So first, make sure that the value arrive where it is supposed to be. And while we are moving the value, we stay in constant mode. As you can see, when I move this value here, I'm using another function, the TDU rand. Okay. TDU rand is a function in which you can put everything and give back a randomized float, 0 to 1. There's some other things that we have to see about the rand function, that are the following. It will never return 1, but may return 0. For a given seed, it will always return the same random number. The seed does not need to be a number. Wow. If the seed is not numeric, it resolves it to a string representation to reproduce a unique value. And that's nice. Just in case. Okay, how to use it? For example, here I'm linking the channel 1 to the channel 2 and the sender to the receiver. Okay. I'm linking those values, but in between I put this random function, so when I move this, I always get a float back randomly. 0, 1, 0 to 0.999999. Okay? How are we going to use that? Actually, we put it in an expression, chop for example, and everything you put inside will give back a unique random number. Then you say, okay, I don't want to have float. No problem. You take a math, chop, you set the integers to ceiling, because we want to ensure that we arrive to 12, and we are choosing ceiling because the guy said that we never return 1, but we want to have it, kind of, so we say like that, and we are sure that we are reaching this number here. Okay, so now if I move this 0, 1, I will have value in integer value between 0 and in the 12. Okay. I make you see that if I type 1 here, I have 4. If I type 44, I have 8. If I type 1 again, I have again 4. We are demonstrating that for a given seed, it will always return the same random number. That's handy. You can loop in the noise. I find it cool. Okay, then for example, you now say, okay, but I want to have everything in that because I need it. Okay, then we are creating an index, okay, and with the index is based on the number of the row. You can do that with a simple for loop that say for all the row that we're putting inside of the script dot, please script dot append a row, and inside of this row always can you please kindly write the number of the same row, and the script dot says of course I can, and we have this. Now, because we are talking about random numbers, we can randomize the index just by using a sort dot, and you wanna sort it for the row specify column index. Specify, it's fair enough, index 0, stay on 0, and then you move the random, and as you can see, we're having back a randomized version of our index. Okay, next one, TDU remap. It works like this. Okay, same things, but directly in Python. I'm proving that it's really faster because I'm putting inside how many? 600 should be, no, 60, let's make 600, okay, there I'm putting a 600 sample inside, and we are cooking half a millisecond. It's not bad. Okay, here is I'm grabbing one sample of this noise with this expression, check for the first channel of the noise, and from it take the sample 45. Okay, then here I'm taking this one, I calculate shuffle it, okay, just to make the calculation more intense, and then I'm referring to channel 45 that is the same. Now I have a noise number generated from a noise chop that is going inside here, it is being remapped by the function that is actually working as the TDU before in our expression, in which I link the custom parameter required to make the function work. Okay, and as you can see, I'm having back what I need. If I have to remap this, then 0 to 5, this guy goes 0 to 5, so no problem whatsoever. Here we go. Okay, nice. Now with this one you should be happy, and you can analyze and have random number and a kind of normalized number. But what if actually you have to normalize a lot of stuff? So here we're actually talking about randomizing things, okay? And now we want to normalize things. How are we going to normalize things? To normalize things very fast, you can do it in GLSL. There's one function that is called normalize, and will normalize your input texture value. So now I'm inputting a noise. This noise is 32-bit float RGBA, means we can actually put any number we want inside. And as you can see, the right up corner is something, is the red value is 8 point something, so we're going above 1, and this is possible only if you put this. Okay, So we are inputting really randomized values, you can see, -1, okay, a lot. What I'm doing here, okay, is nothing special. I'm taking the input and then outputting the same stuff, but normalize. You can just type it like this, fair enough. Okay, then you say, but I have it in top, how can I get it? Easy busy. You can just use this function, the sample. If you refer to a top, you can type sample, then type actually the UV coordinate you want to use in pixel. So now would like to have the right top corner. This is a 10-10 texture, no? So I go the top right corner, 10, 10. I click and then we can compare the red channel. Okay, as you can see here is 0.93 blah blah blah, and this is the same. So we are matching this sample here of this texture with no conversion whatsoever. You take it, you have it, this one. Okay, what if you want to refer to one single directly in chop? Easy busy, same expression. Okay, if you can see here, you have a list. Okay, then directly in chop you can take a constant, for example, constant good to handle value, and you can just type normal is referring to this texture that is a GLSL, and then I want to have this sample value, and from the sample value that is actually a list with 4 values, red, green, blue and alpha, you want to take the first element of the list. To scroll a list you have to use integer. So 0 red, 1 green, 2 blue, 3 alpha, and we have it. Same number that you can see here, and you can read here, and you can read here. If I select it again, 0.93, right? I'm gonna leave you with an interesting things I find out, and this will be a release that I will do just because I open my Patreon, and I mean, if I want to be supported, I have to do something cool. So I find this and I make my way to have a kind of value matrix preset combo things, and I'm still working on it, is this one, and this is a surprise for the next tutorial. I wish you all the good things that can happen in your life. 2 times. Ciao.